Hi Doctor, my name is KUMARAN SELVARAJA from group G1A2. Today we'll do presentation for this question 4, final exam from 2021. Okay. One of the crane in Penang Port are using synchronous motor as their crane operation to transfer the container from the commercial ship to yard. A 208 volt, 45 horsepower, 3-phase, 4-pole, 60 Hz, 0.8 leading power factor. Delta connected synchronous motor has a synchronous reactance of 2.5 ohm and a negligible armature resistance. Its friction and windage loss are 1.5 kilowatt and its core losses are 1.0 kilowatt. Initially, the motor shaft is supplied a 15 horsepower load with 0.8 power factor. Okay, for question A, in order to analyze the synchronous motor performance, sketch the phasor diagram for the machine at the initial load operation. Okay, first, before we draw the phasor diagram, we'll find out the P out. We'll find out the P out first. To find the P out, 15 horsepower multiplied with 746 watt, and then we got 11.19 kilowatt. Okay, from this value, we can find out the value for P in. So for the P in, we get 13.69 kilowatt. And then from the value of P in, we can find IAL. IAL is 47.5 ampere. And then from IAL, we divide by square root 3 to get IA, which is 27.4, angle 36.87 ampere. And then with this value, we can find out our EA, which is 255, angle negative 12.4. Okay, this is how our phasor diagram look like. The red line represents VA, which is 208, angle 0 volt. And then EA1 is 255, angle negative 12.4 volt. And then IA1 equal to 27.4, angle 36.87 ampere. Okay, now I'll pass to my partner, Ryan, to continue question B.
Thank you, Kumaran. I will continue with the determine the output torque of this synchronous motor. So by formula, for the induced torque is 3 multiplied by V phase multiplied by EA, which is your phase and your line voltage, and then multiplied by your sine theta, divided by your VM, which is your efficiency, multiplied by your inductance reactance. So 3 will multiply 255 because the V phase will be 255 multiplied by 208, your 208, which is your line voltage. After that, sine 36.87 because this is the power factor. You got the power factor, which is 36.87. After it divided by 2.5 multiplied by 1800, which 1800 comes from this formula, which is 120 times by your frequency divided by the pole, your Vm, your omega m. After that, you will get 21.22 Newton meter, which is your part of force. So this part of me, I would like to pass to KUAN Yong for the next part.
Okay, Doctor, I will continue with the C. During the operation, one of the container is having a much heavy load for the car. It is expected that the new load is increased to 30 horsepower. What is the new value torque angle? Okay, in degree. For the situation, evaluate the effect of this condition through the phasor diagram. So for the new load increased to 30 horsepower, we can using the equation 30 horsepower times 746 watt to get 22.38 kilowatt, and then we can using the P in formula. For this formula, P out frictions and winch losses and core losses and armature couple losses, then we can get the P in is 24.88 kilowatt. So by using the formula of this, P in equals to 3 voltage PA over SX, and then you can times is since delta. SX is represent your synchronous reactor. So by using the formula, you can find out the delta is 23 degree. So you can see from here the internal generator voltage just becomes EA equals to 255 degree is negative 23 voltage. Okay, the new value for torch will be this one, torch 3 voltage in dash EA sine delta over your voltage times your synchronous motor. So you can get the answer is 13.82 Newton meter. Okay. Next, I will continue to calculate the new line current and motor power factor after the load change and sketch a new phasor diagram. Okay, see this one phasor diagram. Okay. Okay, next one. Okay, we can see from the line current here, and then we can using the formula to find the line current is here 71.4, then the degree is 15 ampere. So we will using the square root 3 currents, line currents. Okay, the current is square root of 3 times 41.2, which is here we can get, and then we find out the answer. The final power factor will be cos 15 or 0.66. This one is the converter leading. Okay, this one is the new phasor diagram. The previous one is here, and then we combination with the IA, the new one 71.4 less than 15. Okay, then another one is 255 less than 23. Okay, this is our presentation. Thank you.